Hey everybody, welcome to semester 2, day 4 of summer school geometry. Today we're talking all about circles. Okay, so I'm just going to start very basic over here and just kind of refresh your mind on circles. So let's say we had just an ordinary circle. We know for sure that this length right here from the center to the edge, we call that the radius. Okay, and then the distance that's twice that amount, so all the way across the circle, is called the diameter. Okay, so we know that basic much. And you also probably remember earlier, in middle school, you might have learned how to find the area. To find the area of the circle, it's pi times the radius squared. So you would need to know what the radius of the circle is in order to find the area of it. Then we also have something called the circumference, the distance around from if you just trace all the way around the circle, that's the circumference. So I'll label that as C. And that is always equal to 2 times pi times the radius. Okay, so that's kind of the basic information or knowledge that you might already have about circles. But now what we're going to do is we're going to talk about circles related to geometry. Okay, if you had a calculator and you wanted to graph the picture of a circle, there's a way to do that. Okay, so the first thing we need to know is the radius. Okay, that's some number, and I'll just use r in this picture. And then the second two things we need to know is where is the center. So what I'm going to do for this general picture is put an x and a y value, and I'm putting this little c here to indicate that that's the x coordinate of the center, x sub c, y sub c. So that means the coordinate, whatever these values are right here, the coordinate of this middle point. So these are the things we need to know about our circle before we can write an equation for it. Okay, so now over off to the side, I'll write the general format of the equation. We're going to start with x as our variable, and what we're going to do is we're going to subtract the x coordinate of the center. So x minus x sub c, we're going to square that. Then we're going to have plus y minus y sub c, just the same way we did the x's, square that, is equal to r squared. Now notice how this kind of looks a little bit like Pythagorean theorem. It's because it's derived or based off of the Pythagorean theorem. If you look closely here, we can kind of see if we can draw like a right triangle right here. There's triangles that you can draw within a circle, and that's how a circle is actually created. So that's where this kind of looks similar to that. Okay, so now let's see an actual example of this to see how it works exactly. So this example down here shows us exact coordinates. So what I'm going to do right here is first I'm going to figure out what is my radius, this length right here. Now we can't just guess what it is. We have to figure exactly out what it is. And the way we do that is we use a right triangle. Notice how I can draw this right triangle in here. Now I can use Pythagorean theorem. This is 1 and this is 4. So 1 squared plus 4 squared is equal to my radius squared. My radius is the hypotenuse of this little triangle right here that I drew. So this is going to be 1 squared. 1 squared is just 1. 1 plus 4 times 4 is 16 equals r squared. So 17 square root that is equal to the radius. So here's our radius. The radius is equal to the square root of 17. And now I'm going to label x center and y center because that will help me write out the equation, just like I wrote up here. So what I'm going to do now is I'm going to copy this so you can kind of see it down here. Okay, so there's my template or my general format of a circle equation. And I'm going to replace everything that I see in this problem. So I have x minus xc. xc is a 4, so x minus 4 squared. All right, plus y minus and I look at my YC, it's a -3. So I'm going to put Y minus -3. Remember, if there's a negative in there, you have to put the extra negative in there because the initial formula for a circle already has Y minus YC. So if YC is negative, this needs to become a negative. Or you can think two negatives make a positive. So you can change this actually to a plus sign. You flip the sign and you still have squared. And then I have radius squared. We figured out the radius was 17. So square root of 17 was the radius, so that thing squared. Here's my equation of a circle. What I'm going to do here is I'm going to test this to make sure it works and it's accurate, just to double check that I wrote my equation correctly. So now if I look at my two circles, they look very similar to each other. They are actually the same thing. I can look at the exact coordinates and see that they match up. Like if you notice, this coordinate right here looks like it's going pretty close to the 7. And you can see the same exact thing right here. It's going pretty close to the 7. Okay, so these two circles are the same exact thing. Our equation is correct. So that's how you would write out the equation. Okay, now we can apply this and figure out some other types of applications of using circles. So this problem, it's another similar type of problem you might see in Delta Math. It says the diameter of a circle is 12 meters. So a diameter is all the way across, don't forget that. So if this is 12, then half of it is the radius, which is 6. So let's find its area in terms of pi. That means leave pi in your answer. Okay, leave pi in the answer. All right. So we said earlier the area of a circle is always pi times r squared. So this is pretty straightforward. A equals pi times our radius is 6. 6 squared. A is equal to 36 pi. And we can leave it at that. When we leave our answer in terms of pi, you just leave the pi in the answer. Then we have this next question says the area of a circle is 25 pi inches squared. What is your circumference in inches? Express your answer in terms of pi. So again, here we have this circle. It's telling me that the area, all of this in here, everything, is 25 pi on the inside. That's the area. If I were to shade all of this in, okay? What is the circumference? Now we know that the circumference, like I said earlier at the top of the page, the circumference is equal to 2 pi r. We also know that the area here is equal to pi r squared. But we can replace that with 25 pi because it tells us that this is the area and it equals pi r squared. So if this is the case, then I can solve this equation for r. If I have pi on both sides, I can cancel out the pi. And now I have 25 is equal to r squared. So that means that r is equal to 5 because 5 times 5, 5 squared is r. And now I just take r and I put it in my circumference equation because it's asking me for what is the circumference in inches. So take r, plug it in over here. So that means that c is equal to 2 pi times 5, 2 pi times r. So that means 2 times 5 is 10 pi. There's your circumference. Okay. So there's your examples for today. Everything about circles, all to do with circles. So go ahead and take a look at your Delta Math assignment now. If you have questions, please do not hesitate to email me or you can message me on Canvas.